Okay. So to catch people up online, we talked about for our warm-up, and you can pause this if you need to, 2 to the what is 8, 2 to the what is 16, 2 to the what is 1/16, that's 3, 4, and -4. It's really easy to do these problems when we know that it's a whole number, but it's really hard when it's something like 2 to the x equals 11. We know that 2 to the third is 8, and 2 to the fourth is 16, so obviously it's something between 3 and 4. We talked about when there's an x in the exponent, you got to use a logarithm, because a logarithm is the opposite of an exponent. Opposite of adding is subtracting. Opposite of multiplying is dividing. Opposite of an exponential function is a logarithm. Okay, they undo each other. So if you're trying to get something out of an exponent, you use a logarithm, like this. So 2 to the x equals 11. Write it so that you have a little bit of space. Now I'm going to put a log base 2 on both sides. Why do you think I chose a log base 2?
Because 2 is the number.
Because 2 is the base over here. And then we're left with x equals log base 2 of 11. And this is something you can actually put in your calculator and find an answer with, okay? It's called the change of base rule, and here's how you do it. You take log 11, and you divide by log 2. And you take the bigger number divided by the smaller number. And when I say the bigger number, hey, look at me, please. When I say the bigger number, I mean like, you know how this one, not like 11 is bigger than 2, but like physically, the 2 is the base. So the base goes on the bottom. Whatever this tiny number is there goes on the bottom, and this one goes on top. What is the automatic base in your calculator? 10, because we've got 10 fingers and toes. We count in base 10. So everybody in your calculator right now, you're going to hit the log key. Log is to the left of 7. You're going to type in log 11 divided by log 2. And we got 3.459 approximately. So let's see if we can test that out. 2 to the power of 3.459. Now, does it get us exactly 11?
No.
No, why?
Because you have to plug in that whole number there.
I'd have to plug in this whole number plus everything behind it to get exactly 11, right? Because it's not a whole number, it's just an approximation, but it's pretty close. So, that's how you use a logarithm. Let me explain how you read a logarithm. Log base 3 of 9 is 2. So 3 to the second power is 9. So this is the base. This is the power. And this is the answer. So we're going to do one of those worksheets, which I think you guys actually like when you do like worksheets like this, yeah?
Yeah.
We're going to do one of these worksheets, and I'm going to, you have to do the whole thing for tomorrow, but I mean, you're going to get, I would say in the next 15 minutes, I would say we're going to get, if not all the problems, almost all the problem stuff. I'm going to do like 4 of them with you, but they're like, okay, real fast. So let's do these together, and don't do that thing where you're like, I'm going to ignore her and just work on my own, and then ask me a few seconds how to do it.
Why can we just cross off log?
It's kind of like, okay, do you remember how I told you that an exponential function and a logarithm are opposites of each other? So like if I had 2 and then I wrote -2, those would cancel each other out. So that's why those cancel each other out. If it was a log base 2 and a base of 3, that would not cancel each other out, just like 3 and a -2 would cancel each other out. And you'll start getting used to it. Let me give you one just to look at. All right, so we're going to start. You have to do the whole thing as your homework, but the first page is so fast you'll probably get through it in, I would say, 3 minutes. and the back page is slower. Now, I'm going to take you through and do some of them with you. Let's do number 1 and number 9 together on the front. On the back, let's do number 1 and number 7 and 8. Okay, so start on this side. Log base 7 of 1 over 343. So 7 to the what power is 1 over 343? -3. Let's find out. So if I took, we know that the negative puts it on the bottom, so that's definitely right. And then 7 to the power of 3 is 343. So the answer to this one's -3. Because 7 to the -3 equals 1 over 343. You do not have to write this part down. I'm just trying to explain why this works. This first page is really easy math. It's just basically like translating, essentially. It feels like it's translating into a different language. So tell me number 9. 6 to the what power is 36? 2. Because 6 squared is 36. You were thinking multiply it by 6, right? But the answer is 2 here because we're trying to figure out the power. Turn to your partner. Do like 2 more of them. You pick. Remember, it's not what it's multiplied by, it's what power is it?
No, it would just be 2. Or wait. Okay, so if we know that -4 is 1/16, then I have no clue where I'm going with that.
Are there any of these that you would like me to tackle right now because you both got stumped on one? 8. All right. 64 to the what power equals 1/4? That's pretty tough. So we're trying to get to, let's see, if it was 64 to the -1, what would that be? One over 64, okay? What if it was 64 to the what power equals, or to the what power equals 8? What kind of power would make something do a square root? Do you guys remember what power is equal to a square root?
We're doing a fraction,
Yes,
so
1/2. So we can do a fraction power to make this work. Okay, we know that it's going to be negative, right? Our answer is going to be negative because it's underneath a fraction. So now we need to figure out 64 to the what fraction is going to get us 4. Anybody have a guess?
1.09.
Okay, it's not going to be like, it's going to be a whole number probably like in a fraction. So like 1/3, 1/2, 1/5, 2/5, something like that. We're trying to get to 4.
1/3, right?
Let's try it. 1/3. Sorry. Should be a divided sign there. Yes. So it would be -1/3. That one's a tough one. I think that's the toughest one though on the sheet. Because the third root of 64 is 4. That's a tough one.
Wait, so how do you put it in your calculator? So you want
Put what into your calculator? You could do that.
Yeah, but I keep taking
Come here.
Yeah, I thought more of it.
And there's nothing to do with degrees and radians.
Should be.
This one's -7. No, -2.
You didn't divide it. You just multiplied them by each other.
Oh. Wait, did I do that for like any of them?
You have not been thinking about any of these, you've just been typing them in?
No, I thought about most of them.
You should.
Wait. Oh no, I divided for everything plus.
Number one on the other side?
No, wait.
It's not by itself on the left after the log. You need it to get just n by itself to be able to log.
No, you have to get them to have the same basis first. All right, now we're gonna try number 1 on the back side. All right, you guys ready? To get into that exponent, actually, maybe we'll start, let's start with number